Okay, in this video we're looking at increasing and decreasing functions and the first derivative test. So if you find the derivative of a function and you find its critical point, so where is f of x equal to 0, or if you were to find f prime of x and you figure out where it's greater than 0, in other words you have a positive slope, then anywhere where you have a positive slope the function is increasing. That makes sense. And anyway, you have a negative slope, or the derivative is less than 0, then it is decreasing. So let's look at an example of that. Find the intervals in which f is increasing or decreasing. So here's f of x, some function, x to the third minus 3 over 2x squared. And so I take the derivative. I'm finding critical values. So f prime of x equals 3x squared. The 2's will cancel here, so minus 3x. I want to know where does this equal 0 so I can find any critical points. Where is the slope 0? Factor out of 3x. I get x squared minus 1. And that factors into, oh, sorry, it's not x squared minus, just x minus 1. And so I can see that the critical points are at 0 and 1. So I have two critical values where the slope is 0. What I want to know is we're looking for intervals where this function is increasing and decreasing. So what I want to know is what is the slope just before this, just after this, and in between this. So what I'm concerned with here is what is f prime of, let's say, -1. Any point below 0, so we'll use the closest one because it's an easy number to plug in. So we're plugging -1 into the derivative here. We're not so much concerned with the value. We just want to know what the sign is. So if I plug in -1 and I square it, I get 1 times 3 is 3. 3 minus 3 times -1, which is -3. So 3 minus -3 is 6. So I get a positive 6, which is greater than 0. So this is positive, which means it's increasing. So this function is increasing from -infinity all the way up until that first critical point of 0. So this -1 was just a test point. If I test f prime of, let's say, a half, I've already worked it out. I get -1/3, -3/4, which is less than 0, which means it's negative, which means this function is decreasing. So it's decreasing between 0 and 1. So on the interval from 0 to 1, this function is decreasing. And then if I plug in f prime of 2, which is just a test point that's above 1, I will see that I get 6, which is greater than 0, and it's positive, so this function is increasing, and that's increasing from 1 to infinity. Notice these are open brackets, so we're not including 1, because at 1 we have the slope is 0. So the graph of this function looks kind of like, let me see. So the critical point was 0. If I plug that back into the original function, I get 0, 0. So right there. And if I plug in the, 1, I get -1/2. So I'm like here. So this function looks like this. Because those are the only two critical points, it's the only time that the slope is 0. It's the only changes that are going to occur. So that's why I can say from -infinity all the way up until that first critical point, this function is increasing. So any point that I would have used as a test value below 0 would have given me a positive answer. So this function is increasing, then it's decreasing, and then it's increasing. And those are the intervals. So that's finding intervals where the function is increasing and decreasing. And then we have the first derivative test. First derivative test, which just is really simple and sort of obvious. It says that if a function is increasing and then suddenly decreasing, that critical point must have been a maximum because you were going uphill and then you were going downhill, so you must have been at the top of the hill. So if you go from increasing to decreasing, then C, we'll call it C, at C, then you have a relative max. Remember, this is not an absolute. We did a previous video where we found absolutes on a closed interval. You found the critical points, and then you tested them in the original function as well as the endpoints to see what the highest and lowest y values were. Those were absolute mins and maxes. This is a relative min and a relative max. And so you're just looking for where is it increasing and where is it decreasing. And the same thing, of course, goes here. If you're decreasing and then increasing, you must be in a valley, sort of at the bottom of the hill. So you decrease, and so if you go from decreasing to increasing, then your critical point must be a relative minimum. And you could find the the y value again by plugging that in. So you had -1. I'm sorry, that was 1, -1/2 was a minimum here. This was 1, -1/2, and then this was 0, 0 was your max. And that's it. That's what the first derivative test says. So first you want to test intervals, see where it's increasing and decreasing, and then once you've done that, you'll be able to determine where your min and max is located just by looking at where is it increasing and where is it decreasing. That's it.